Is there a series and induction formal homework? This is question 4. Part 1 says express 4 over r upon r plus 1 upon r plus 2 in partial fractions. That's not even a further maths partial fractions one, that's just a regular one. So I hope we're okay with that. So the way we would set this up then is going to be 4 all over r plus 1, r plus 2. I would go for a over r plus b over r plus 1 plus c over r plus 2. Get our common denominator, so we're going to go 4a upon r plus 1 r plus 2 plus b r upon r plus 2 plus cr upon r plus 1. If I let r equal 0, I'm going to get 4. This disappears, this disappears. What do we have? 4 equals 2a. Obviously gives me a equals 2. If I let r equal minus 1. If I let r equal minus 1, this whole term disappears. This whole term disappears. I end up then with this. Minus 1 times 1 gives me, I think, a minus b, doesn't it? So that b equals minus 4. And if I then let r equal minus 2, I get 4 equals minus 2. That whole thing disappears. That whole thing disappears. Minus 2 upon minus 1 gives me, I think, a 2c. And so I get c equals 2. That means I can rewrite my original question. Let's move us up a wee bit and see where we are. So my question was express this in partial fractions, or r plus 1, r plus 2. We can rewrite that then as, what do we have? 2 over r minus 4 over r plus 1 plus 2 over r plus 2. Okie dokie. It then says, let's move this back down again, hence show that the sum between 1 and n of this is equal to this. Goodness. So let's take a wee look then. So part 2, I hope you see the word hence. Hence means using what we worked out in the first bit, and what we worked out in the first bit was that this here is the same as this. So effectively we are being asked then for the sum between r equals 1 and n of 2 over r, take away 4 over r plus 1 plus 2 over r plus 2. I hope you see where I'm getting that from, because that was the original question in part 2 and I just subbed in those values there. So what is this equal to? If I start putting in the numbers into this, let's see what we get. If I put the number 1 into this, I get 2. And if I put the number 1 into this, 1 plus 1 is 2. I'm just going to write it as 4 over 2. If I put the number 1 into this, I get plus 2 over 3. If I put the number 2 into this, plus 2 over 2 minus 4 over 3 plus 2 over 4. If I put the number 3, sorry, you've lost me, haven't you? So what have I done here? I have subbed the number 1 in here for this. I've subbed the number 2 in here for this. And I'm now subbing the number 3 in. Plus 2 over 3 minus 4 over 4 plus 2 over 5. And you'll start to see the pattern appear fairly soon, I hope. 2 over 4 minus 4 over 5 plus 2 over 6. Do another one. Plus 2 over 5 minus 4 over 6 plus 2 over 7. I'm sure we can find a wee pattern in there. Plus dot 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 plus and then plus for our usual thing. So we're going to sub in n instead of this. So this will of course be 2 over n minus 4 over n plus 1 plus 2 over n plus 2. The previous term would be 2 over n minus 1 minus 4 over n. The previous term here, 2 over n plus 1. So now I need some sort of Houdini move to see if I can get something to cancel here. And what we're looking for is to see what's going to cancel. So here it is. Are you ready? 2/3 and 2/3 cancels out with minus 4/3, and that gets our pattern going. So 2/3 plus 2/3 gives me 4/3. That cancels out with that. Do you see how that's all going to cancel out now? I hope you do. 2 over 4 cancels with minus 4 over 4. This and this will cancel with this. That means this and this would cancel with the previous one, and this one would cancel with this one. That means, what do we have? This one and this one would cancel with the one above, and this one here would cancel with that as well. So what are we left with? We are left with, on the top here, we have 2, take away 2, plus 1. So down here, then we will have a 1. And then these terms here at the end, let's see, we have 2 over n plus 1 minus 4 over n plus 1 and 2 over n plus 2. So those two are the same denominator, so that's minus 2 over n plus 1 plus 2 over n plus 2. And we're getting pretty close here. We have 1 minus. Here's what we're looking for, if you vaguely remember. And if you set these up then as a common denominator, you'll see how it works out for us. So let's see. Hopefully you can see here, we're quite close to the bottom of the page. I am. What do I want to do? So I want to do minus 2 upon n plus 2 plus 2 upon n plus 1 all over, that's added there, isn't it? N plus 1 upon n plus 2. So I find a common denominator times top and bottom of this one by n plus 2 times top and bottom of this one by n plus 1, and that all cancels out because you have a minus 2n, you have a plus 2n there, you have a minus 4 there, don't you? You have plus 2, so it ends up just with a minus 2 on the top. So my final line is going to be 1 take away 2 all over n plus 1 upon n plus 2, which is what we've been asked for there in the question. Okay.